Hello and welcome to the coding session Trading Signals episode 6. Um, Today we are going to be looking at uh, some bugs that we need to fix at the trading strategy, something that was not working in the previous episode. And if we have time and we can get it done quickly, we will try to synchronize a bot that is emitting signals with a bot that is receiving signals, probably using the candle of the simulation they are running at. Okay, so let's get to the code. First things I first thing I'm going to do is to run a network node. So I will do this node network. This will run the one of my two network nodes, the one that is configured at the environments file. Okay, I will not run it inside Visual Studio Code because I don't need to. So that is good enough there. Then I will start the SuperAlgos platform. Okay. And let's recap a little bit. When I was executing the lightning strike strategy, at the end of day one, there was an exception, an unhandled exception that I don't know why. I could reproduce it without the signals, but then that was last night. But today, it's like it doesn't reproduce it. It's not reproducible without the signal. So we will see what we can do. So the first thing I'm going to do here is go go to my trading task, and I'm just going to run it. I'm not going to turn on the bot receiving the signal, so this will go just to the network node, and from there it's going nowhere because there is nobody listening. Okay. But anyway, I will do one run of this just to show what the problem is that I'm trying to fix now. So I'm going to run the task. Also not in debug mode, that means that it's going to be running here. Okay, connected to the network node. And I'm going to run here. As you can see, when it is not in debug mode, it goes faster. Still not as fast as I would like. But one thing that slows things down are these messages. So we can avoid these messages because then it goes fast, as you can see. So let's find this message and remove it because we are not interested in that anymore. I'm struggling a little bit with this Visual Studio Code. Sometimes it finds the stuff quickly, sometimes it doesn't. I still haven't figured out why. Okay, so I will not need this anymore. Well, Well, I will comment this. Also, I'm seeing that I'm not evaluating the possibility here that the network node sent me a response that he couldn't process my signal. So um, I will add this to do something when the network node would not process its signal. Maybe we do something, maybe we don't, but um, it's something to solve later. Okay, so this already ran. The problem was at the end of the simulation here. When it finished the simulation, it crashes. Okay. Um, so what I'm going to do, just to see how big the impact of those logs are, I'm going to run it again. I want to see if it goes faster. So run. Okay, no more logs. I think here it goes slowly because it's putting orders, and that is what the strategy does. It puts some orders early on, then it puts orders at the end of the day. And when there are no orders, then it goes very fast because it is not uh, inside a position. Okay, and it looks like that what slows this down a lot is probably the fact of being sending the signals. That is something that I would like to figure out. What is exactly the thing? What is exactly slowing down this stuff? So there is some slowdown there at the 600 candle. Then it slows down again, almost at the end of the day. Goes very fast. At the end of the day, goes reduces the speed, especially in the last candles. So let's check out this for a minute. If I'm not mistaken, this is the lightning strike sending signals backtesting session. Okay, so as you can see, this struggles a little bit here, and at the end of the day, when it has to put this mm, it's not that it's not trigger on, because it's trigger on during the whole process, but and it's putting and canceling this order all the way. um, okay, so I need to focus either on the problem of speed or on the problem of this crashing. So let's try to solve the problem this crashing. Mm, Let me get this. To solve the problem of why this is crashing, I think I'm going to debug, but there is an issue with debugging this kind of bug test that it at a certain point this stop working. I don't know exactly why, but if I want to run it the whole day in Visual Studio Code, it just won't work. So what I'm going to do is to hack a little bit this, and at the trading simulation where there is a loop, where there is a loop, where is the loop? Here. This goes from candle number 0 to 1400, whatever. Okay? And the crash happens when this actually ends. So I want to know what happens at the moment it crashes. Um, who is calling the function that is crashing? Because what I've seen so far is that this trading system object is undefined, and and is probably undefined because this is the finalize function somewhere over here. Initialize, finalize function is being called, and then a condition is evaluated after that, but I cannot understand why or how this is happening. So to approximate myself more into the problem, what I'm going to do is to to add a trick here. I'm going to say here, if e equals 0, then we are going to jump to e equals 1440 is the last candle. I'm going to say 38, two candles before. Okay. So let's see if it continue crashing. Hopefully it will. So we run the task, we run the session, and it seems that it finished, and it seems that it crashed. Which is good, because that means that it's not going to be that difficult to debug it. So I'm going to do it in the extreme, going to almost the last candle. I'm going to run it. Okay, it's waiting for the session to be run. Good. Then I'm going to run it here, and it should crash again. And it does. There is this sandbox mode that somebody left somewhere. Let's see if I can find it. It doesn't look that it crashed the whole task, or probably it does, but because I see two more loops here. Okay. Somebody left this by mistake. Okay. Um, 1 second. Okay, so what I'm going to do now is that I'm going to run it, but from here, from the, and I'm going to debug it. Okay, I'm going to do one run and see if it crashes from there. Okay, it's running inside here, and I'm going to run the session. Stop in here. Okay, going to just let it run. Just let it run. I don't need it to stop. Okay, here it gets undefined and then it crashes. Then it's called again because it's trying to process the next day. Undefined again, but it doesn't seem to crash again. Okay, well, yeah, it did crash because now Visual Studio Code is not running anymore. So in fact, it did crash. Okay. Next step, run it again. Run it one more time. And debug from here. It will be running. When it gets here, I'm going to continue step by step to figure out how it gets again into a condition with that unloaded, with that undefined. So I will run the session. Oh, what is going on? It got stuck from the previous run. Okay, I'm going to stop this. Probably try to stop this. Stop this. I'm not sure if this is going to recover. This is not really 100% well prepared for you to be shutting off the stuff at any point. But okay, it recovered. So we have the run button here. The run button here. So we'll run it again. We'll debug here. And we'll run this one, the session. Okay, so this is the beginning of the simulation. We'll let it run. Here the session is being finalized. The trading system is being finalized. So let's see how this goes. At the same time, I want to put a breakpoint at the condition, at the place that is executed. Well, it's executed somewhere here, but I want to know if this tries to get inside here at some point in time. So I will continue this. Await write files. I don't know exactly what does. Trading simulation. Write files. Okay, write files enter into eval condition. This is the problem because this is trying to use trading system while it's undefined. So we're getting closer. Why is getting inside there? You can see it watching the call stack a little bit. Um, let's explore a little bit the call stack. What I see at the call stack is that all this eval node and um, trading system eval. Okay, I can go one by one, but it's the same function calling itself recursively at the request of somebody. I don't really see who. Trading system eval conditions. Check close stage event. Check if stages need to be closed. Run with status is open. Or is open. Run open stage. This is very strange. What is going on? Because supposedly we were trading simulation. We were here at write files. My guess is that what is going on here my guess is that what is going on is that there is something related to asynchronic calls of functions, something that is executing out of time. What I will do is it's not easy to get where is this coming from the call stack. Eval conditions, but who is calling this? Check close stage event. And why is this being checked? I don't know. Check trading system, eval condition, close stage event. So it has it looks very much as a synchronization problem between calls to asynchronic functions, and at some point but probably the easiest way is to run this again. Let's run it again. Let's check the user interface. Okay, um, I will turn it off. I will turn. I will stop this so as to have again the. What I'm going to do is run this again. The, and I'm going to go step by step after is undefined, the trading system. Okay, so this is running, debug, run. Okay, so now I go step by step. I will put at the trading system a breakpoint at the condition. Yeah, well, these write files, right? So what happens here is that it, when the file is written, then it cuts the sequence of execution sequence, and it continues somewhere else. That most likely is what is going on. Oops. I touched something that. Okay, sorry for that. It seems that F11 interferes with the recording window. Okay, we enter here. Essentially, we are going to write the output files, all the files generated by, starting with the daily files. So here it comes, write output file. Oops, you see, there is no relationship in the sequence of execution between the write files and this eval condition. It's like this eval condition was requested at some point, um, but not awaited. There's like an await missing somewhere. These are quite difficult problems to solve. And yeah, this is a problem. Here it is. Here in initialize of the trading system is doing an eval node without an await. And I'm not 100% sure that is the problem, but it looks like something is not good there. Um, yeah, at least here, well, there is an easy way to know if this is the problem. We will just change it. Let's stop this, and once it stops, we will run it directly, not in debug mode, but in console mode. So, okay, run. Okay, to have an await there, this should be an asynchronic function. Oh my god. Okay, now it got stuck there. Beautiful. So we will run it here because we can easily stop it if needed. Debug. Okay. We'll run the session now. Start the simulation. Eval condition. It finishes, so I can well, it didn't crash like before, but it dropped me somewhere else at the trading system. to continue after this eval. Probably this is one one frame upwards on the call stack. I will put again the eval condition. Another thing here is that if eval condition is not an async function, so I don't know how it is playing out in the end, because the formulas are async functions because they might get a signal, or they might send a signal, or they might talk to the portfolio manager. But conditions, okay, how does this continue? I am pressing F10, but it looks quite stuck there. Still running, but no idea where this is gone. So I don't know exactly what happened. We try to run it directly on the at the console. Once this recovers, okay, the problem is not solved, obviously, still there. So what I will need to do is to analyze a little bit better the usage of these asynchronic functions inside here. I don't know exactly what can happen, because the thing is that we are calling from trading stages. We are calling these eval conditions without awaiting this, okay, which is kind of correct because nothing asynchronous happens inside there. So eval conditions comes here, but it makes an await eval nodes. Why it makes an await eval nodes? I'm not sure about that. Um, Probably shouldn't, but this is recursively going to do an await eval node. I think the problem was introduced after the formula after the formula so before portfolio manager and signals, the function to eval formula was not asynchronic at all, but it had to become asynchronic. The problem is that if this function is called from inside this one eval node, and from eval node also we have another path of execution that is for evaluating conditions. So there is a mixture between await and not await, and async and not async, that I don't really know what is going to happen, or what exactly is going on here. So maybe one solution for this is to declare this eval condition as an async function and make it all async, even though if it is not async, but just standardize it. And there's one more guy here, eval JavaScript code, that probably is the user-defined code. Yeah. So what I'm going to do is I'm going to bet on this. So if it works for one, it should work for the others. Well, hopefully. So I put a sync there. So there is an await here, an await here. I'm going to await this one and await this one. Okay, and this is the eval node. And maybe await this one and make it async here. So let's check the eval conditions. There are 9. We are going to await this one. Number 1. Number 2 is the one that we did, or no, number 9. Just checking that it is everywhere. Check check close event. I bet this is needed. And also this call needs to be awaited. Okay, so what I did is to await the calls of eval conditions and make sure they are all inside asynchronic functions. So in that way, I should avoid what is going on now, that is jumping from one place to another, totally unrelated. My guess is that this should solve the problem. So let's check it out. I'm going to run it at the console. Okay, running. Going to run it here. Okay, run. Good sign is that this continue working there. So problem solved. This is logging that the trading system is finalized. It's finalized, but the strategy doesn't crash. The execution doesn't crash. Amazing. One problem less. Let's run it again without the log. Okay, here we go. Let's run this guy. Now that it's running, I'm going to run the other guy. Okay, now I'm going to remove let me check my current changes. I need to remove the hack at the trading simulation loop so that we can calculate all the candles. I will keep this one. I will discard this one. This seems to work. I will keep these changes and also these changes. Perfect. Um, okay, the last thing I want to do is to, well, two things. I'm going to run this again with all the candles just in case. Which is probably already running. No, it's running again. So I will run it with all the candles. Here it goes. Slows down there. Well, I bet this is going to work now. My final test would be running the lighting stride strategy and making sure that everything is working, data mining at the, I'm talking about the lighting strike at the getting started workspace, okay? Because I was modifying the logic of how this works. I will make sure that visually I can see that the strategy runs well. And if everything looks good, I will commit all my changes from now and yesterday, create a pull request so as to update the develop branch so that this bug doesn't affect other people. This is looking good. Okay, it finished. No more problems. Problem solved. Okay, so let's go for the test that everybody should do. The minimum test for sending something, sending a pull request, you need to come here, getting started tutorials. First, you save your work. Then you switch to the getting started tutorial workspace. It might take a few seconds. So when this loads, the test you need to do is the following. First, you come here to be 100% sure that you're not seeing like already calculated data. Come to platform, my data storage project, algorithmic trading, and you delete this folder. This is all the data of previous executions of trading bots. So we are going to come here and run these data mining tasks. So this should work. Monitor this, that it works well. First fetching candles from the exchange. Then candles being processed, then resistance and support working well. I haven't touched anything about this, so I would be surprised if it didn't work. But anyways, okay, 100% there, 60, 80, 100% there. So this is working. Then we come here and execute this lightning strike strategy. We deleted all data, so if data appears, it's because this ran well. We run the bot, the session and the task, I mean. It's pretty fast. Saving, it finished. Okay, it's waiting to be run again. Then you come to the charts, unlock the automatic search for September 1. Oh, I'm too slow today. Okay, zoom in, go to 1 minute. Okay, and there it is. Okay, this is the execution of the trading strategy for 1 day. I already know that it should look like this, and it pretty much looks well. So I would say that everything is working. Now I feel okay to go and contribute this. The way I do it is I have one workspace to run the command, because there I have my GitHub user token. So that's where I'm going to go, and I run this command contribute. So on the project trading signals, bug fixes, and we reach the point where we can um, run a trading bot sending signals and another one receiving them. Okay. So I go there. When it's done, a good practice is to go to GitHub, to the SuperAlgos repository, and check if your pull request is 100% there, which it is in this case. And here it has all my work from today and yesterday. Okay. So this is pretty much episode number 6. Here we started with a bug that was not really very easy to figure out how to spot it. One of the problems that we are having is that when there is something to debug that is not happening at the beginning of the simulation, for some reason the the trading bot running inside Visual Studio Code is simply crashing the Visual Studio Code, not necessarily the bot, because the bot running outside runs well, but it has something to do with the fact that it's being debugged. So it's not easy to get to the point where you need to reproduce the problem. So the lesson learned here is that you can hack the simulation, but making it jump to whatever part of the simulation is having the problem, like I did, and that it was at the end of the day. And by doing so, if the problem is still being reproduced, then you can get closer and closer. In my case, um, analyzing the call stack was not really useful because it was a very long call stack with a lot of asynchronic calls, but at least make me point me into the direction that there might be some problem with synchronizing functions that are being called in an asynchronic and not asynchronic way. And when that is kind of mixed up, then you will have some behaviors that you will not probably understand. So what the solution for me in this case was to standardize, and because some functions were calling asynchronic function and also not asynchronic functions, so I standardized them like if they were all asynchronic functions, and that's all the problem. That's all the problem, and we verify it by running the strategy fully and by running the lightning strike and see it at the chart that it generates all the output that we usually see there. So I hope you learned something at this episode. Um, Next, what I will do is uh, I have to like two things to do. One could be investigate what is slowing down the signals, the bot that is emitting signal. That would be cool to know. And the second thing would be to synchronize a bot that is sending signals with the one who is receiving so that it can act, they can be synchronized at the same candle. Okay. So we don't want to consume signals standing in one candle that were produced at some other candles because that would be like crazy. So that is what is we're going to do uh, in next episode. So in this for this one, thank you for watching and see you in the next one. Bye.